The National Electrical Code, or NEC, mandates that satellite dishes be grounded for both lightning protection and overall electrical safety. Grounding conductors must adhere to specific sizing and installation guidelines. The minimum conductor size is number 8 American wire gauge, or AUG, solid copper conductor. Installation requires that the conductor be routed as directly as possible to the grounding electrode conductor, or GEC, of the electrical system. To properly ground a satellite dish, firstly, identify the grounding electrode conductor, which is typically a metal rod or pipe driven into the ground outside the house. Secondly, connect the number 8 AWG solid copper conductor to the grounding electrode conductor using an approved grounding clamp. Thirdly, route the conductor directly from the grounding electrode conductor to the satellite dish, avoiding bends and turns that exceed 45 degrees. Fourthly, attach the conductor to the grounding lug on the satellite dish using a grounding clamp. While the NEC does not specify a maximum distance limit for the grounding conductor, it does recommend minimizing the distance. A distance of 25 feet is often considered reasonable. However, if the distance to the grounding electrode conductor is greater than 25 feet, it is acceptable to use a larger conductor, such as number 6 AWG or larger, or install an additional grounding rod closer to the dish. While individual dish providers may have their own training requirements for installers, these requirements must comply with the NEC. If installers claim that the dish provider requires a shorter grounding distance than what is specified in the NEC, then this is incorrect. It is imperative to always insist on following the NEC requirements for proper grounding to ensure safety and compliance. Proper grounding of a satellite dish is essential for protecting your home and equipment from electrical surges and lightning strikes. Ignoring the NEC requirements can lead to dangerous situations and potential damage. By following these guidelines, you can ensure that your satellite dish is grounded correctly and safely. The grounding electrode conductor, or GEC, is a critical component of the grounding system. It connects the electrical system to the earth, providing a path for fault current to flow back to the source. This path helps to trip circuit breakers or fuses, quickly disconnecting the power and preventing electrical shock or fire hazards. The grounding electrode conductor is typically made of copper or aluminum and is sized according to the size of the service entrance conductors. The grounding electrode itself can be a ground rod, a metal water pipe, or a concrete encased electrode. When connecting the grounding conductor to the grounding electrode conductor, it is important to use an approved grounding clamp. These clamps are designed to provide a secure and reliable connection that will not corrode or loosen over time. Avoid using makeshift connections or wire nuts, as these can be unreliable and potentially dangerous. When routing the grounding conductor, it is important to avoid sharp bends and turns. Sharp bends can increase the impedance of the conductor, reducing its effectiveness and carrying fault current. Keep the conductor as straight and direct as possible. If bends are necessary, make them as gradual as possible. The grounding lug on the satellite dish is specifically designed for attaching the grounding conductor. Use a grounding clamp that is compatible with the lug and ensure that the connection is tight and secure. Do not simply wrap the grounding conductor around the lug or use tape to secure it. These methods are not reliable and can lead to a loss of ground. The NEC provides detailed requirements for grounding and bonding electrical systems. It is important to consult the NEC and any applicable local codes to ensure that your grounding system complies with all requirements. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install or inspect your grounding system. Remember that proper grounding is not just a matter of following the rules. It is a matter of safety. By taking the time to ground your satellite dish correctly, you can protect yourself, your family, and your property from the hazards of electricity. In cases where the grounding electrode conductor is located far away from the satellite dish, consider installing a supplemental grounding electrode closer to the dish. This can help to reduce the length of the grounding conductor and improve the effectiveness of the grounding system. A supplemental grounding electrode can be a ground rod or a ground plate that is driven into the earth near the satellite dish. Connect the grounding conductor from the satellite dish to the supplemental grounding electrode, and then connect the supplemental grounding electrode to the main grounding electrode conductor. This creates a parallel grounding path that can help to reduce impedance and improve grounding performance. When installing a supplemental grounding electrode, be sure to follow all applicable codes and regulations. Also, be sure to avoid underground utilities such as gas lines, water lines, and electrical cables. Call your local utility companies before digging to locate any underground utilities. In addition to grounding the satellite dish, it is also important to ground any other metal components that are part of the satellite dish system, such as the mounting bracket and the coaxial cable shield. These components can become energized during a lightning strike or electrical fault and can pose a shock hazard. Grounding these components helps to ensure that any fault current is safely conducted to ground. To ground the mounting bracket, connect a grounding conductor from the bracket to the grounding electrode conductor or to the supplemental grounding electrode. To ground the coaxial cable shield, use a grounding block or a grounding adapter that is specifically designed for this purpose. The grounding block or adapter should be connected to the grounding electrode conductor or to the supplemental grounding electrode. Proper grounding is an essential part of any electrical system. It helps to protect people and property from the hazards of electricity. By following the NEC requirements and taking the time to ground your satellite dish system correctly, you can ensure that your system is safe and reliable. Always remember to disconnect power before working on any electrical equipment. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous and can cause serious injury or death. Grounding is a critical safety measure that should not be overlooked. The NEC specifies the minimum size of the grounding conductor based on the size of the service entrance conductors. For most residential applications, a number 8 AWG copper conductor is sufficient for grounding a satellite dish. However, if the service entrance conductors are larger than 200 amps, a larger grounding conductor may be required. Consult the NEC for specific requirements. In addition to the size of the grounding conductor, the NEC also specifies the type of conductor that can be used for grounding. Only copper or aluminum conductors are permitted for grounding purposes. The conductor must be insulated or bare and must be suitable for direct burial. The NEC also requires that the grounding conductor be protected from physical damage. If the conductor is exposed to physical damage, it must be installed in a conduit or other protective enclosure. The conduit or enclosure must be securely fastened to the surface and must be made of a material that is suitable for the environment. The grounding electrode conductor must be connected to the grounding electrode using an approved grounding clamp. The grounding clamp must be made of a material that is compatible with the grounding electrode conductor and the grounding electrode. The clamp must be securely fastened to both the conductor and the electrode and must provide a reliable electrical connection. The NEC also requires that the grounding electrode be located as close as practicable to the service entrance. The grounding electrode should be located outside the building and should be accessible for inspection and maintenance. The grounding electrode must be driven into the earth to a depth of at least 8 feet. If the soil conditions are such that it is not possible to drive the electrode to a depth of 8 feet, the electrode must be buried horizontally in a trench that is at least 30 inches deep. The grounding electrode must be made of copper, aluminum, or galvanized steel. The electrode must be at least 8 feet long and must have a diameter of at least 1/2 inch. The NEC provides detailed requirements for grounding and bonding electrical systems. It is important to consult the NEC and any applicable local codes to ensure that your grounding system complies with all requirements. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install or inspect your grounding system. Remember that proper grounding is not just a matter of following the rules. It is a matter of safety. By taking the time to ground your satellite dish correctly, you can protect yourself, your family, and your property from the hazards of electricity. Grounding systems are designed to provide a low impedance path for fault current to flow back to the source. This path helps to trip circuit breakers or fuses, quickly disconnecting the power and preventing electrical shock or fire hazards. A properly grounded electrical system is essential for the safety of people and property.